All right, guys, we're on the back side of day 8 notes of unit 9, and we have a few equations, and they're asking us to to find the solutions or the zeros of each of the following equations in simplest a plus bi form. So on the front side, they didn't say simplest a plus bi form, but we did it anyways. But when they do tell you that, that really means that all of these roots or solutions are going to come out with an imaginary part to them. And that kind of tells me that don't even bother factoring. So even though factoring is one of our methods of solving for solutions or zeros or x-intercepts, when they say a plus bi form, that tells me that factoring kind of don't even try to bother. All right. That factoring will never, ever, ever kind of get you with imaginary. Although sometimes we're going to have to use factoring in certain situations. So I know that's a little bit tricky, but we kind of see what we're dealt with and then pick a method. All right, so in number 4, here we go. It says x cubed plus 18x equals 0. So the cool thing is that we're already equal to 0. And I can see that I have an x cubed instead of an x squared. And so I can't use quadratic formula in this one, at least not yet. All right. But we do see that there's an x in common between the terms. And so we're going to go ahead and pull that out. And so we're going to be left with x squared plus 18. So in this case, we did have to factor a little bit. Okay. But what we have left, x squared plus 18, there's going to be two solutions that come from there. And we could use the quadratic formula on that part of what we have here, x squared plus 18. But I'm going to show you guys that you can go ahead and still solve just because there's no middle term there. All right, so as of right now, I can't factor anymore here. But going down here, x as one of our factors, when it gets set equal to 0, that is one of our solutions, okay? On this side, when we set x squared plus 18 equal to 0, we could use the quadratic formula. Factoring will no longer work, though, on it, but quadratic formula could still work. You just have to realize that your b term, which is normally attached to x, we don't have it. Therefore, b would be 0, and we would sub in a 0 for b in the quadratic formula. But just a little bit easier, we could go ahead and subtract 18. And we end up with x squared equals negative 18. And then we could go ahead and square root. However, we're going to have to remember that when we square root or even root two sides of an equation, that there's two answers, and those two answers are represented by the plus minus symbol. Okay. And then we're going to go ahead and say, oh, square root of a negative 18. If we break that up into 9, 2, and negative 1, 9 times 2 times negative 1 would give us that negative 18. And then we could go ahead and say, well, square root of 9 becomes a 3. The square root of negative 1 becomes the I. And then the square root of 2 would come down. And there are our three answers. We have x equals 0 as one answer. X equals 3i radical 2 is a second answer, and then x equals negative 3i radical 2 is our third answer. And there are our three solutions, and then we knew we were going to get 3 because the highest exponent is 3. Okay, let's take a look at number 5. So in this one, a little bit tricky there with the whole fractions, but good news, we are equal to 0. Okay? We do know that there's going to be two answers in this one. And so what we're going to do is we're going to try to get rid of those divide by 3s. Okay, and we're going to do that by making 0 into a fraction by putting it over 1. And if you remember way back in the beginning of the year, if everybody has a common denominator, then we can go ahead and ignore the denominators. And so we're going to multiply this fraction by 3 on the top and 3 on the bottom. Okay, and so we end up with this 3, and because we have an equal sign, this 3, we don't have to worry about them anymore. And so we end up with 4x squared plus 98 equal to 0 times 3, which is 0. Okay, and so there ends up being my equation. Okay, we are still equal to 0. We still have two answers. We could go ahead and try to factor it if we wanted to. We could pull a 2 out if we wanted to. Or we could go right to the quadratic formula and sub in our values. There are multiple ways of solving it, right? But I usually tell you guys first type of factoring you should always check for is GCF. And there is a 2 that you could pull out. You can't pull out a 4, but you can pull out a 2. And that'll be a 2x squared left over plus 49 equal to 0. Okay, this 2 is a factor, but when it gets set equal to 0, there are no values of x's to solve for. And so none of our solutions come from there. Both of our solutions will come from this one. Okay. And again, it is quadratic. You could put the values into the quadratic formula, or we could do what we did on the other one, is subtract 49. And we'll be left with 2x squared equals negative 49. Okay. If we divide by 2, that gives us x squared equals negative 49 divided by 2 is a decimal, so we could leave it as negative 49 divided by 2. Okay. And then we could go ahead and square root. And when we square root, we have to remember that there's two answers. So we'll say x equals plus or minus to represent those two answers. Okay. And then we got something goofy going on here. We got the square root of negative 49 over 2. And so we're going to go ahead and rewrite that as the square root of negative 49 over the square root of 2. And on the top, we're going to replace that with the square root of 49 and the square root of negative 1, so that we can go ahead and replace that with 7i. And so we end up with 7i over radical 2. Okay. And we'll go ahead and leave that as plus or minus 7i over radical. Oops, I'm too far down. Let me just move this up a little bit so I can write square root of 2. All right, and there's your two answers. So you have x equals 7i over radical 2, and then you have x equals negative 7i over radical 2. And there's your two answers in simplest a plus bi form. Okay, I won't read you too much about that one. All right, let's take a look at number 6. Okay. And in number 6, we have another equation. However, this time we're not equal to 0. And so that is crucial that we get equal to 0. So we're going to go ahead and subtract 2. And we end up with 1/2 x squared plus 18 equals 0. Okay. And now we can go ahead and we could factor by pulling out a 1/2, but that gets a little bit strange. Or we could just go ahead and go right to solving. Up to you. All right, so we're going to go ahead and subtract the 18 back over. And then I'm going to go ahead and multiply both sides by 2. And I end up with x squared equals 36. Oops, sorry, that my 18 should be negative. So then negative 36. Okay, and then go ahead and square root both sides. However, you have to remember that that's where your two answers is going to come from, the plus minus. And then the square root of negative 36, if you think about it as the square root of 36 and the square root of negative 1, we're going to get 6i. And there's our two answers. So x equals 6i and x equals negative 6i. All right, let's take a look at number 7. And in number 7, again, we're not equal to 0. So we're going to go ahead and keep everything over here. But we're going to add our 54x on over, so we are now equal to 0. Okay, and with an x to the 4th, we're going to get 4 answers in this one. And it's already kind of set up for factor by grouping. So we're going to group. Okay, and out of the first group, we can pull out x cubed and be left with x plus 6. Out of the second group, we're going to pull out a positive 9x and be left with x plus 6 equal to 0. You guys can see my x plus 6's. We're going to pull that out as our greatest common factor and be left with x cubed plus 9x. So one thing that I didn't check for all the way back in the beginning is that I actually could have factored out an x. Every single one of our terms had an x, and I actually forgot to check, but that's okay. I noticed it now, and I can do it now. So what I'm going to do is out of this factor here, I'm going to pull out an x and be left with x squared plus 9. Okay, and then that other factor of x plus 6 is just going to come down. All right, and so we'll still be equal to 0. And I cannot factor anymore, although some people will try to factor this one right here as a D2PS, but you have to watch out. It's a plus sign, not a difference, not a subtraction sign. And so you can't factor that one actually. So the only thing I can do now is go ahead and set each factor equal to 0 and get my solutions, okay? So x is a factor, it gets set equal to 0, and that is one of my solutions. Okay, x plus 6 gets set equal to 0, and x will equal negative 6, and there's a second solution. And right here in the middle, guys, you guys can see the square term. You're going to get 2 of your solutions from this factor here. All right, and the only thing I can do, guys, is subtract the 9 over. okay, so that it's x squared equals -9. And then I'll square root both sides, which is where my two answers are going to come from. And so I have x equals plus or minus, and hopefully you guys know by now that the square root of -9, the square root of 9 will be the 3. The square root of the negative is actually square root of -1, which becomes the I. And there are my other two solutions. And so I end up with x equals 0, x equals -6, x equals 3i, and x equals -3i. And there are my four solutions. Two of them are real and two of them are imaginary, okay, or non-real. Very good. All right, let's take a look at one more, number 8, I mean. And it says that the solutions to this equation are what? And so if you look, all of your choices look like they have been using the quadratic formula, okay, after they do the simplifying with the heart pretzel. However, guys, we can't use our quadratic formula yet because we are not equal to 0. So we're going to go ahead and subtract 9. And we are left with 5x squared minus 2x. 13 minus 9 is a positive 4. And we're equal to 0. Okay. I'm not even going to bother factoring because, like I said, looking at all your solutions, okay, this would be non-real because it's got the I in it. This is also non-real because it has the I in it. Okay? Square root of 66, this would be irrational. Okay? And square root of 21 is also irrational. So you're never going to get those four answers, whichever one is our actual answer, from factoring. So we'll go ahead and use the quadratic formula. So we'll say A equals 5, B equals -2, and C equals 4. And then we'll go ahead and go x equals -b plus or minus square root of b squared minus 4 times a times c all over 2a. And we'll go ahead and clean it up. We get a -2, so that's a positive 2, plus or minus, and we're going to type in all of this underneath. Make sure your -2 is in parentheses, being squared, and that should give you a -76 when you type it all in, all divided by a 10. Okay, and with -76, we're going to go ahead and break it up into the perfect, a not perfect, and the -1. So now we just have to focus on the 76, and the largest perfect that goes in is 4, and it goes in 19 times. Square root of 4 becomes a 2, square root of the -1 becomes the I, and the square root of 19 comes down, and we're going to go ahead and rewrite this, okay, as x equals 2 plus or minus 2i square root of 19 all over 10. We'll go ahead and do our little heart pretzel here to simplify there and here. And we end up with x equals 2 divided by 10 is 1/5. Keep the plus minus. And then this 2 divided by that 10 is also a 1/5, but you don't need the 1 on top because you have the I square root of 19 still up there, but you can have it there if you want to. And there is our answer. We just have to match it to one of the following, and we're going to get rid of choice 1 because that has a square root of 21. We're going to get rid of choice 4 because that has a square root of 66. We're going to get rid of choice 3 because that also has a square root of 66. And then we're going to make sure our answer matches choice 2. And there's my 1/5, plus or minus. They write the I in the back behind the square root of 19 over 5, which is the same thing as the I in front of the square root of 19 over 5. And so we're going to pick choice 2. All right, guys. I will see you guys on the next unit and for day 1 notes. All right, bye.